Hi there, Mr. Holcomb here with another episode of The Math Behind the Modules. This is Lesson 7, Measuring Variability for Skewed Distributions. Interquartile range, the IQR. That would be Q3 minus Q1. All right, let's move on. Exploratory challenge. Challenge 1. Exercises 1 through 3. It says skewed data and their measure of center. Consider the following scenario. A television game show, Fact or Fiction, was canceled after 9 shows. Many people watched the 9 shows and were rather upset when it was taken off the air. A random sample of 80 viewers of the show was selected. Viewers in the sample responded to several questions. The dot plot below shows the distribution of ages of these 80 viewers. Okay, so this is a distribution of ages of people watching that show that got canceled. So here's the dot plot. And yes, there is no nice center rounding up bell-shaped curve. It's kind of spread out, and then there's this majority of data is over here. So this is looking like that. So that's skewed left. It says approximately where would you locate the mean, the balance point in the above distribution? Well, when you're looking for mean, you're kind of looking for a center. I would say probably somewhere in this range, so that half is on this side and half is down here. And of course, these ones that are further away are going to pull the average over, so maybe it got pulled this way a little bit. And that's what you need to think about. But here's the answer. Okay, so an estimate that indicates an understanding of how the balance would need to be closer to the cluster points on the high end is addressing balance. An estimate around 45 to 60 would indicate that students are taking the challenge of balance into account. Number 2, how does the direction of the tail affect the location of the mean age compared to the median age? Okay, so an answer to that would be the tail is on the left, down this way, which means that the data are skewed to the left. The mean is typically in the direction of the tail, so the mean age would be to the left of the median. And I indicated that. I said that the mean was getting pulled this way because of that, but the median would not change. Number 3, the mean age of the above sample is approximately 50. Do you think this age describes a typical viewer of this show? Explain your answer. The answer to this would be students should compare the given mean to their estimate. The mean as an estimate of a typical value does not adequately reflect the older ages of more than half the viewers. So if we go back and look at this, and we look at the mean age of 50, that would put my mean right here. Okay? So does that represent viewers? And I would say no, because 60s and 70s looks like the majority of the viewers were between the ages of 60 and 75. So the mean is not a good representation of this data. Number 4, exploratory challenge 2, exercises 4 through 8 says constructing and interpreting the box plot. Okay, using the above dot plot, construct a dot, I can't talk today. Using the above dot plot, construct a box plot over the dot plot by completing the following steps. 1, locate the middle 40 observations and draw a box around these values. Okay, so in doing this, locate the middle 40 observations. First thing we need to know is how many there are total. So if I come down to this, let me get rid of my arrow here. Okay, there's 3, 4, 5, 6, 7, 8, 9, 10, 11. Actually, how many did it say? Did it give us a total? A random sample of 80. Okay, so if I want the middle 40, then I want to eliminate the other 40, which is 20 on each side. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So I would put my line right there. Then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, and I would put my other one here. So there is the box. Step 2 says to calculate the median. And then draw a line in the box at that location. So the median you would count over, since we have 80, the median would be halfway between 80 is 40. So it's right around the 40 mark, 40. So I've already counted 20, so let's just continue this way. Either way, it doesn't matter. I just counted 20 over this way. So now I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So I would put my median right here between this 20 and this 20. So there's my median. Number 3 says draw a line that extends from the upper end of the box to the largest observation in the data set. Okay, so that's a lot of people call this a whisker. So here's my highest value of my data point. So all you're doing is drawing a line from there to there. And then finally, the last step says draw a line that extends from the lower edge of the box to the minimum value of the data set. I keep going the wrong direction here. So from the box to the minimum. So there is, well, a little too far, about like that. And there is our box plot. So this is the minimum, this is the maximum, this is the median, this is quartile 2, and this is Q3, or Q1 and Q3. All right. So recall that the 5 values used to construct a dot plot make up the 5-number summary. What is the 5-number summary for this data set of ages? What is the minimum age? Okay, so instead of going back and forth now, I'm just going to copy this and bring it over. Okay, so I don't have to flip back and forth from page to page. Here's what I'm going to do. The minimum age is right here, and that is 9, 8, 7, 0, 2, 4, 6, 8, 10. 2, 4, 6, 8, 10. I don't know what they're using for a dash here because there's 1, 2, 3, 4, 5, 6 to get us to 10. All right, so I'd say the minimum age is right around 5. Let's just do that. How about 5? Now the lower quartile, or Q1, which is right here, is 40. Median is right here, and that is, I would say, 60. Upper quartile, which is Q3, is right here, and I would say that would be 70. And the maximum looks halfway between 70 and 80, so I would call that 75. Okay, so the age range is 5 to 75. Lower quartile is 40, median is 60, and upper quartile is 70. What percent of the data does a box plot capture? Well, these are quartiles. They're called quarters for a reason. So this is 1/4, and this is 1/4. Oops, not a half. This is 1/4, and this is a quarter, and this is a quarter. That's why they're called quartiles. So it says, what percent of the data does the box part capture? So it's asking how much is this? Well, it's 2/4, or 1/2 of the data, which is 50%. It says what percent. Number 7 says, what percent of the data falls between the minimum value and Q1? So that's here. And it's 25%. Number 8 says, what percent of the data falls between Q3 and the max? Well, Q3 and the max is this whisker here, and that's 1/4, or 25%. Okay, so exercises 9 through 14 says an advertising agency researched the ages of viewers most interested in various types of television ads. Consider the following summaries. Then here it is. Data. Ages, target products of service. 30 to 45, electronics, home goods, cars. 46 to 55, watch ads of financial services, appliances, and furniture. 56 to 72, retirement planning, cruises, healthcare services. Okay, that's what they'd be interested in. 9 says the mean age of the people surveyed is approximately 50 years old. So there's the mean. As a result, the product producers of the show decided to obtain advertisers for the typical viewer of 50-year-olds. According to the table, what products or services do you think the producers will target? Based on the sample, what percent of the people surveyed about the fact or fiction show would have been interested in these commercials if the advertising table is accurate? Okay, so let's discuss this answer. It says the target audience would be viewers 46 to 55 years old. Obviously, if they're 50-year-olds, they would be in this range. 50 is between 46 and 55, so this is the age range we're talking about. And what are they interested in? Financial services, appliances, and futures. Furniture, I mean. Financial services, which is futures. Appliances and furniture. Okay, so then it says 12 out of 80 viewers, or 15%, are in this range. Well, how did we find that? 46 to 55, we would have to go back up to here. And 46 is here, and 55 is, so it would be these guys. So it looks like 11 or 12. So maybe they included this one here. Okay, so 46 to 55. So that would be right there. It's hard to tell because they use 6 hash marks between tens, which doesn't make any sense. But anyhow, so it's 46 to 55, and there were 12. So 12 out of the 80 viewers is 12 over 80, which reduces to 6 out of 40, which reduces to 3 out of 20, and there's 5 20s in 100. So now if I multiply both of these by 5 over 5, I get 15 out of 100, which is 15%. So that's how you could do that without a calculator. Okay, number 10. The show failed to generate the interest the advertisers hoped. As a result, they stopped advertising on the show, and the show was canceled. Kristen made the argument that the better age to describe the typical viewer is the median age. What is the median age of this sample? Okay, so if we go back to the chart, the median age is right here, 60. Okay, so the median age is 60. What producers or services does the advertising table suggest for viewers if the median age is considered as a description of the typical viewer? So 60 is here in this group, so it would be retirement planning, cruises, and healthcare services. So here's an answer written in complete sentences. The median age is 60 years old. The target audience based on the median would include the ages of 56 to 72 years old. Target products for this group are retirement planning, cruises, and healthcare services. Number 11. What percent of the people surveyed would be interested in the products or services suggested in the by the advertising table if the median age were used to describe typical viewers? Okay, so what they're saying is if we wanted the middle, if we were using median, we would want the interquartile. Okay, so what percent is that? Well, it's 50%. It's half the group. The box part of the box and whisker plot is the 50%. Okay, so let's take a closer look at this though. What percent of people surveyed would be interested in the products? So we're talking 56 to 72-year-olds. So if I go back up here, let me erase this mess. So I want to get rid of all this stuff. So 56 to 72-year-olds would be right about here to here. And there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. Oh, I didn't go far enough. I only went to 70. It's 56 to 72. Okay, so it's those as well. So 2, 3, 4 and 4 is 8. That's 11, 13, 17, and 6 is 23. 24, 25, 26, 27, 28, 29, 30, 31. Okay, so we'll use those 31. So it would be 31 out of 80. Okay, and this one doesn't reduce because 31 is prime, so I'd have to use my calculator. So let me do that just to get a handle on that. If you're now using the Webbit, and so clear 31 divided by 80 is 0.3875, or approximately 39%. So it's not 50%. Okay. Number 12. What percent of the viewers have ages between Q1 and Q3? The difference between Q3 and Q1, or Q3 minus Q1, is called the interquartile range, or IQR. Sound familiar? I think I started the lesson by saying that. IQR, Q3 minus Q1. Okay, so they've mentioned that here. What is the IQR for the data distribution? All right, so I need to know what Q3 is, and we wrote that down. I only have to go to my chart. Q3 is 70, and Q1 is 40. So to get used to this, I would say IQR equals Q3 minus Q1. Write the formula, and you will memorize it. If you use this every single time they're asking you this, then you'll remember, oh, the interquartile range is Q3 minus Q1. And if you write it every time, it helps you remember. So IQR equals, and Q3 was 70 and 40. So then I'd substitute my givens, 70 minus 40. So the IQR equals 30. Okay, number 13 says the IQR provides a summary of the variability for a skewed data distribution. The IQR is the number that specifies the length of the interval that contains the middle half of the ages of viewers. Do you think producers of the show would prefer a show that has a small or large interquartile range? Explain your answer. Okay, so a smaller interquartile range indicates less variability. So it may be easier to target advertisements to a particular group. A larger interquartile range indicates more variability, which means the show is popular across generations but harder to target advertising. So we want a small IQR. Number 14, do you agree with Kristen's argument that the median age provides a better description of a typical viewer? So is the median better than the mean in this situation? Okay, so in this case, the median is a better description of a typical viewer for this audience because the distribution is skewed. Now we're on to an exploratory challenge of exercise 3, or challenge 3, exercises 15 through 20. Now, students at Waldo High School are involved. Where's Waldo? Do you know where Waldo is? Do you know where Waldo High School is? Do they use red and white stripes on their flag? All right, I'll stop. Students at Waldo High School are involved in a special project that involves communicating with people in Kenya. Consider a box plot of the ages of 200 randomly selected people from Kenya. Box plot of ages for Kenya. So here's our box plot. And we have asterisks out here. What are those? Okay, so a data distribution may contain extreme data. Specific data values that are unusually large or unusually small relative to the median and the interquartile range. A box plot can be used to display extreme data values that are identified as outliers. Okay, so there's a term. They are outliers. Each asterisk or star in the box plot represents the ages of 4 people from this sample. Based on the sample, these 4 ages were considered outliers. So our age range is from, well, if this is 20 and this is 10 and this is 5, I'd say age range would be from like the age of 2 or 3 all the way up to 100. Okay, so I'm just getting a grasp on my range. All right, so now let's answer some questions. 15 says, estimate the values of the 4 ages represented by an asterisk. All right, so again, I'm going to copy this since we're answering questions about this. It's on a different page. Okay, so here we go. Copy this down. It says to estimate the value of the 4 ages. So let me draw vertical lines from here straight down. Let's try to be as accurate as possible. A ruler would come in handy here. We're all about accuracy in math. Alrighty, there's another one here. And another one here. Okay, so what ages are those? That's what this question's asking. So I would say that this is, I'd say approximately 72 maybe, this one. Okay, because 70 would be halfway between 60 and 80, maybe 72. This might be 77. Okay. And maybe this one is 82. And this one's obvious, it's right on 100. Okay, so estimate the values. There they are. Okay, so moving on to number 16. Let me move this down. Put it here. All right, so an outlier is defined to be any data value that is more than 1.5 times the interquartile range away from the nearest quartile. Okay, so you need to know this. The definition of an outlier. How do we find that? Well, we want Q1, we want Q3. We want the IQR, which is Q3 minus Q1. So the range of the box times 1.5, and whatever that value is, anything greater than that or anything less than that the other way is going to be considered an outlier. So it says, what is the median age of the sample of ages from Kenya? So again, I'm going to use a line segment here. Let's change it to orange. And I'm going to try to draw a line straight down like so. And it's under 20. Let's say it's 18. Okay, so let's say the age is 18. What is the median age? So the median equals 18. What is the approximate value of Q1? So again, I'm going to draw a segment so I can be fairly accurate. So it's from here straight down. And they're going to ask for Q3's value, which is from here straight down. Okay, so now that I've done that, well, this is 10, halfway between 0 and 20. So I'd say, I don't know, 7, 8, somewhere around there. Let's say 7. Let's let Q1 equal 7. Okay. And Q3 is a little bit more than 30. So how about 32? Let's let Q3 equal 32. Alrighty, so there we have it. What is the approximate IQR? So I'm going to write the formula again. You need to remember this. IQR equals Q3 minus Q1. So the IQR equals Q3, which is 32. That looks like 3 subscript 2. So IQR is 32 minus, or IQR is 32 minus Q3, 32 minus Q1, which is 7. So the interquartile range is 32 minus 7, which is 25. So the interquartile range is 25. Okay, so we're making progress here. Hopefully you understand all these steps. Let me move this. Number 17 says to multiply the interquartile range by 1.5. What value do you get? So an outlier equals IQR times 1.5. So the outlier is going to equal 25 times 1.5. So the interquartile range, or the outlier, is going to be anything greater than that amount over the Q3 and less than the amount subtracted from Q1. Okay, so 25 times 10, or 25 times 1 is 25, and half of 25 is 12.5. So 25 plus 12.5 is 37.5. Or you could have just gone to your calculator and said 25 times 1.5 equals 37.5. Okay, so the IQ, the outlier would be 37.5 greater than Q3, or anything that's less than Q1 minus 37.5. Okay, so number 18 says, here, let's move this again. Maybe I don't even need it anymore, so let me delete it. Number 18 says, add 1.5 times the interquartile range, or our outlier value from 17, to the third quartile, age Q3. So it's Q3 plus 37.5. And our Q3 was 32. So it's 32 plus 37.5, which equals 69.5. Okay? And are these asterisks all above 69.5? So here's our box plot back again. So where can I put this? Let's just throw it right here. So it says, what do you notice about these asterisks? Well, 69.5 is, here's 70. So 69.5 is right about here, and these are all to the right. Okay, number 19 says, are there any age values that are less than Q1 minus 1.5? So let's check. So Q1 minus 37.5, which is our 1.5 times our interquartile range. And Q1 was right here. And what did we say Q1 was? We listed it somewhere. Was it under here? Q1 is 7. Okay, so if Q1 is 7, then we take 7 minus 37.5 and we get negative. So I'm just going to do this here. 30.5. Well, can you be negative 30.5 years old? No, it doesn't make any sense. You can't go below age 0 or you're non-existent. Okay, so are there any age values that are less than this? If so, these ages would also be considered outliers, and the answer is no. 20 says, explain why there is no stars or asterisks on the lower side of the box plot for ages of the people in the sample from Kenya. Okay, I've said it, but I'll write it. An outlier on the lower end would have to be a negative age, which is not possible. Okay, that is the end of lesson 7. Review this very important lesson summary and go do your problem set.